Okay, welcome back to Tectonics Cluster Topic 3. This should be video number 4. Okay, this is continuation and then moving on forward a bit with video number 3, which covered the disaster risk factors that will affect disaster risk. Okay, so for this final portion here, we will be looking at exposure and how by varying the degree of exposure, people and properties will be suffering different degrees of disaster risk as a result. So one of the most key things when you're looking at exposure is population density, right? Basically, I think we learned this in lower sec geog. It's the per unit square number of people per unit square of area. So the higher population density means that you have more people living in that area, compared to somewhere which has a lower population density. Okay, just to bring you back a quick recap. If you are in a class of 24 versus you're in a class of 40, right, the population density inside the classroom with class of 24 would be lower there because you have more space, you have more distance between one another, you have the opportunity to put more space between one another, and overall it should be more pleasant to live in a location like this. Of course, there are other factors that come into play when you look at comfort and all, but population density simply means that. So, if you are thinking of it along the lines of disaster risk, right? What's the highest potential number of fatalities that a classroom with 24 residents or a country with 24 residents versus a country similar size but has 40 residents? Okay, the highest potential will be higher if you have higher population density. So that's important. Now, the extension of that would be, where do you find places with higher population density? So in our context in Singapore, right, we don't really have rural components, rural parts of Singapore. You may think at this moment in time, the far edges of Punggol, Sengkang may be very rural. Actually, if you've really been there or if you live there, you will know that that's not true, right? So if you are in a city area, a developed area, urbanized area, you will definitely have higher population density. So these are the places that if they get hit by um, hazards, tectonic hazards, okay, earthquakes, volcanic eruptions, these are places that will have very high potential of suffering a lot of disaster risk because your exposure number is very high. Okay, so if you look at major cities, okay, when you have major earthquakes happening in major cities, the population density, high population density will result in larger number of fatalities or injuries normally. Okay, can this be offset? Yes, of course. You remember there are two other factors besides exposure, right? So if you have able to crank up the mitigating effect of the other two, your total number of risks can be mitigated even if you're in a very high density area. Okay, now what is the one that is a bit harder to offset in terms of volcanic or not, in terms of tectonic disaster? It will be distance from epicenter. Okay, so the nearer you are to the epicenter, the larger the impact will be versus the further you are away from it. So if your, for example, epicenter is the white dot here, right, and you have other aftershocks around as well. In the Haiti earthquake, why is it that Port-au-Prince was so badly hit? It's because it's very, very near the epicenter. Okay, when you're very, very near the epicenter, as the waves come out, it is at full strength. So it will hit you at full strength. If you are located much further away, the seismic waves will have been weakened by the surrounding area, be it the rockfall, be it the surrounding land. It will have absorbed some of these seismic waves, and by the time it hits you, you would probably suffer less. Okay, I wouldn't say you won't suffer, depending on how big the magnitude of the earthquake is. You will suffer less if you're further away from it. This is also useful in thinking about how Singapore, as a location away from the Sunda Trench, which is past Sumatra to our southwest, right? Why is it that we don't get very severe shaking? Why is it that we tend to live escape scot-free even when Sumatra gets hit by relatively large earthquakes? Because we're never very near the epicenter. Okay, the possible epicenters are possible. It doesn't mean that it must happen along the fault line. It can happen further inland as well. But the most common, most frequent heavy earthquakes, strong earthquakes, they tend to be nearer to the plate boundary itself, which is a distance away from us. So we benefit from this. Right? So exposure, those are the two factors that we deal with in terms of exposure. If you are able to tweak your population density, then you are actually tweaking the total potential amount of people that can be exposed to the risk. However, with modern development and humans' propensity to cluster together, that is not exactly easy to do. So many a times it is locational things that we can do. Try not to locate your big cities near plate boundaries. Okay. However, then again, that is also not always a choice. Some countries are just located for now in a place where everywhere you can pick a capital city is going to be near some fault line. Right. But these are two things that we need to consider in terms of exposure, together with the other two factors when you're tabulating impacts of different factors, or how do you tweak mitigation methods among these different factors to minimize or to reduce disaster risk. So take a minute. You may want to take a look at your notes again, right? Consolidate the three factors that come into play. How would you argue for maybe a location like Jakarta, which is very, very near uh, the fault line? How can you toggle to minimize their disaster risk? Okay, what can you do? Will it be exposure? Will it be mitigation? What would you do? Okay. Now, the next portion that I want to cover in this video would be some of the factors influencing disaster risk caused by volcanic eruptions. So now we're looking at volcanic eruptions, no longer looking at earthquakes. When you're looking at volcanic eruptions, two main things come to mind: chemical composition of the magma, as well as vulnerability of the conditions on ground, okay, available of surface and groundwater, uh, that will lead to the development of lahars. If there's no water, then there will be no lahars, okay? Prevailing wind conditions, which can cause a widespread distribution of ashfall and tephra, and also exposure in terms of where you find your human settlements. Okay, remember when we talked about volcanoes earlier on in the second topic of this cluster, we looked at the very end, we looked at the reasons why humans like to still live near volcanic areas despite all these uh, dangers that exist, right? So this is one of the other things that we can look at. So for this video, I will only be looking at chemical composition. For vulnerability conditions, we will look at it in video 5. So earlier on, we talked about composition of the magma material at different zones due to the type of plate boundaries that you have. So if you have oceanic plate that will subduct and that will melt into the mantle area itself, your composition will have a lot more silica. Okay, you will also have a lot more chemicals within it. Okay, so this is important because then that chemical composition of the magma influence the type of volcanoes form, influence the type of volcanic eruptions that you experience in the area itself. Okay, so location wise and type of volcano is important in terms of thinking of chemical composition, right? So if you are looking at low silica lava, it is fast flowing, it is low in terms of viscosity, so it's not very thick. It's like water, so it can cover long distances. Okay, shield volcanoes, right? How shield volcanoes form? The eruption process, very little explosions, right? It tends to be slow creep. So what does it actually look like, right? So I want to play this in the background. Let's not have the sound. So play this in the background. This is a Hawaiian volcano that erupted in 2018. Now, if you look at the total damages, right, there are 24 injuries, no reported deaths, 700 homes destroyed, and 800 million US dollars worth of property damage. So it's a bit strange, right? You have very few actual human casualties or injuries, but the amount of damage is very, in terms of money wise, economic damage is very big. What does this mean? This means that actually in this type of eruption, shield volcano eruptions, the movement of lava is very slow. So there is a way for the humans to evacuate, right? So houses like this, a lot will burn down, right? This is actually not arson. This is fire started because of the lava creep forward. It touches the house, it touches the flammable material, and then it burns. This is a sped up video. So you look at the lava, it seems to be moving very quickly, right? But this is shield volcano lava. Okay, so this is low silica, low viscosity, and it just slowly creeps forward. It bubbles up and it creeps forward like this. So as a result, if you are able to be mobile, right, if you are able to hold your possessions with you, like you live in a camper van, you don't live in a house, you could escape this rather easily. But human things that are locked in place, your house that has foundation built into the ground, right? These are things that will get destroyed. So if you analyze the type of damage, cost, economic cost, human cost, you are actually able to come to a conclusion of, okay, possibly what kind of volcanic eruption you're dealing with here. What kind of chemicals are you looking at? High silica, low silica. Okay, high silica lava, short distance, but very explosive, possibly forming ash clouds, pyroclouds, tephra, your volcanic bombs. Okay, so similarly, this is a volcanic bomb. So imagine the ball of lava this size is ejected out and it hits onto your roof. Okay, your roof is destroyed, your house is destroyed. Even those that don't get ejected out far away, they rolls downhill. You can't stop this because this is burning hot. Okay, thousands of degrees is still burning hot. Okay, so whatever is in its path gets destroyed as well. Okay, so imagine the amount of damage that this can actually cause if it was ejected further out. Whatever it hits is totally destroyed. Okay, that is probably about a meter in height, right? The volcanic bomb a meter in height, which is a small one already. Okay, right. Merapi is famous for being a stratovolcano with very destructive eruptions. Okay, pyroclastic flow can travel down 3 kilometers very, very quickly. Yeah, remember pyroclastic flow? We talked about 220 kilometers per hour or more, right? So you can't outrun it. So in a situation like this, you will expect more human fatalities if the area is populated with humans, right? The good news is, once again, when you're looking at volcanic eruptions versus earthquakes, right, you have a lot more lead time. So if your people can recognize that the eruption is coming, there's always a chance, there's not always chance, there's always a better chance of them leaving the location, doing an evacuation of the people in the surrounding areas. Okay, but bear in mind there will be people who do not want to leave. Okay, it's no longer their syllabus, but there are different mindsets of locals who live in these areas. One of these mindsets is a fatalistic approach where they know it's going to erupt, they know there's a chance they will get hit and they may get hurt at the very least, and yet they don't want to leave. Okay, so there are reasons behind this lah. Okay, but logically, if you're a logical human and you know that there's a chance of you being hurt by a volcanic eruption, I think most humans will try to leave. Okay, so I will stop here. The next video we will cover vulnerable conditions as well as exposure. Okay, so we will stop here. Vulnerable conditions and exposure will come in the next video. Right, so take some time, think about where we've talked about. Your examples for your two types of eruption, high silica and low silica, would be, remember, high silica stratovolcano, your Pinatubo eruption, Merapi eruption. Your Hawaiian volcanic eruptions tend to be shield volcanoes, shield volcanoes, so they tend to be low silica, low damage. Right, so I'll see you in the next video.